Hey everyone. Today's problem is going to be linked list cycle detection. And basically we're going to be given a linked list like this. And then as you can see here, there is a cycle. 1 goes to 2, 2 goes to 3, 3 goes to 4, and then 4 loops back to 2. And then it just keeps going like this. But of course there are inputs such as 1 to 2 to 3 like this, which are not cycles because 3 points to a none, and that is the end. So we're going to write an algorithm that's going to detect whether a given linked list has a cycle or not, right? So let's have a look at how we're going to solve it. So the problem with cycles is that sometimes it's a bit hard to differentiate whether it truly is a cycle or it's just a really, really long linked list, right? So if my linked list is like 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, and then it repeats on and on and on, maybe like 500 times, and then I reach the last set of 3, 4, and then there's actually an end here, right? Even though this is really long, it does not have a cycle because there's an end to it. So probably the most straightforward way to solve this problem is by using a hash map. So what we're going to do is we're going to create a dictionary, and then we're going to store the node itself, right? Because although the values are not unique, for example, this number 3 could be a 4, but in the memory, they're still counted as separate objects. We're going to make use of that, right? So we have a pointer, I'll call it P, and then it encounters this node, adds it to the list, encounters the number 2, adds it to the list, encounters this, adds it to the list, encounters this, adds to the list, and then it loops around back to this node, right? And once it's here, it'll always check with a dictionary to see if I've seen this node before. If I've seen this node before, then it means that we're in a cycle. Right, and this is pretty good. The time complexity of this is O of n because we're going to be processing every single node once, and maybe the start of the cycle would be processed twice, right? But generally it's O of n, and then we need this dictionary to keep track, which is also O of n in space. But there is an optimization here. Instead of using a hash map, we could use the fast and slow pointers approach. So this is the same input as we had before, but I've just kind of represented it this way so you can see the cycle more clearly. So I'm going to initialize a pointer called fast and a pointer called slow. Now, slow is going to move 1 unit at a time, and then fast is going to move 2 units at a time. Fast is going to be twice the speed of slow. So if I just make it run, in t equals to 1, fast is going to move 1, 2 will be here, slow is going to be here, and then in the next tick, slow is going to go here, fast is going to move 2 units and be here, and in the next cycle, slow will be here, and fast will move 2 units, 1, 2, and it'll end up in the same location. And this is guaranteed no matter the input. Given a cycle, fast will always catch up to slow. It kind of makes sense if you think of it as a loop. So that guy's going to be like twice your speed, right? And then by the time he finishes a lap, you would have reached maybe somewhere here, and then by the time you finish your first lap, he'll go ahead and meet you there as he completes his second lap. I mean, of course, this makes sense because the starting point is the same. You could have even more like nodes here and the result would still be the same. Fast and slow will always intersect at some kind of node. But why is that? Well, let's go back to our running example. Oh god, this is ugly. Because of this like onset, fast and slow are not going to be starting at the same position, right? This is only true if we literally start where the cycle starts. So even if I plot slow here and then I plot fast like here or something, the result would be the same. Eventually, they're going to meet. And not only are they going to meet, I can guarantee that fast cannot exceed slow without at least meeting. So you would think that there might be a scenario where, let's say fast is here, slow is here, that somehow fast is gonna like skip over slow and end up on this node. So they would miss each other, right? But that will never happen because slow moves 1 unit at a time, fast moves 2 units at a time. So relative to slow, fast is actually only moving 1 unit relative to slow, right? So let's say slow is moving 0 units. So of course, if this is the case, then fast cannot skip over slow without at least meeting. Like look, in this situation, slow would be here, and then fast in the next tick would be here. Okay, what if we try to change it up then? What if fast is here, right? Well, if fast is here, then slow would move 1 unit, fast would move 2 units, and then hey, look at that. We're back in the situation again where they're 1 apart, right? So every single tick, fast is always getting 1 unit closer to slow. Well, hopefully I've convinced you that there are no loopholes in this. This will always work. The way I think about it is that it's basically the same thing as if slow doesn't move at all, and then every tick fast moves 1 unit closer and closer until it reaches slow. Well, if you understand the principles, the coding is pretty easy. We create our variables slow and fast, and then we point that to our input head. And then I'm going to create a while loop, and this while loop is going to keep incrementing until either fast reaches the end or until we find a cycle, right? And because fast is moving twice the speed of slow, if it's not a cycle, then fast is going to get to the end first. So we're going to move fast 2 units, and we know this is safe because the while check has guaranteed that fast is not null and fast.next is not null. So this is going to be a safe operation. Fast goes 2 units, slow goes to 1 unit. If fast and slow ever meet, then return true, there is a cycle. If not, then fast would have reached the end of the linked list and found a none. In that case, we can return false. And that's really it. This is a O of n time complexity code and a O of 1 space complexity code. All right, thanks for watching. Okay, bye. Okay, bro, I forgot to show you the results. So here you go. Okay, bye.